So my mic was muted, so let me start again. Welcome, PEP students. Welcome to another live class. And today being Wednesday, we are going to be doing another performance task. We do 2 performance tasks per week. As a matter of fact, I'm going to play for you now our schedule of classes. We have 5 live PEP classes per week and 6 live CSEC classes per week. So here's the schedule. Please write down the dates, the times, and which session we do on what day. And then we'll come back and dive into the performance task. Hello, students. I know you are busy preparing for your math test and your CSEC exams coming up. I have a very important thing. Do you like my new hat? Thank you. Another important question. Have you ever gotten a math problem simply because of making one little mistake? I'm sure you have, as thousands of others have. Now, in this series, we're going to be looking at that students with all the topics in CSEC math. We're going to look at demystify everything. So you watch every video in this series so that boy make those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong, mathematics is as a result of one error or one? Well, this is absolutely true. Looking at common errors. All right, so I'm now going to share the screen so we can dive into the performance task. Okay. All right, I'm going to welcome into me. All right, performance task. And the title of this performance is Going Nuts. So we're going to be featuring the coconut, right? So we're going nuts tonight. What does it mean when we say we're going nuts, generally speaking?
Crazy?
Going crazy.
Craziness. Going crazy.
Right, so you're going crazy, and we're going crazy for coconuts tonight. All right, so Antoine, why don't you read that first slide for me, please?
Okay, miss. You are with your class visiting a coconut farm in St. Mary. The 35 students will be assigned certain tasks to complete for the day. You are with your class visiting a coconut farm in St. Mary. The 35 students will be assigned certain tasks to complete for the day.
Remember, we always read the question twice. So whomever is asked to read, just go there twice. Okay?
Miss, I read it twice.
Oh, you read it twice? Oh, I'm sorry. I was distracted. All right, so 35 students, and you are one of those. All right, Jer, can you read this question for me, please?
With the help of the farm workers, the students will design wooden boxes to store the coconuts in. 1A. Each wooden box must have a capacity of 450 square meters. Write 4 possible dimensions for the length, width, and height of each box. With the help of the farm workers, the students will design wooden boxes to store the coconuts in. 1A. Each wooden box must have a capacity of 450 square meters. Write 4 possible dimensions for the length, width, and height of each box.
All right. I want each scholar to pick what dimension they will choose for their box. As a matter of fact, it's asking for 4 possible dimensions. All right. So each student will have 4 possible dimensions the box could have. The requirement this box must have a capacity of 450 square meters. What do you mean by that it must have a capacity of 450? By the way, that is an error, so that cubic meters. Okay. And what do we mean by that? What's capacity?
The volume or the space within an object.
Okay, so the volume or the space that is available to be filled within a 3-dimensional object. So wooden box, it's a rectangular box, and so what we want then is for you to find the dimensions, the length, width, and height that could give a volume of 450 cubic meters. So each person dimensions. As soon as you've so, just remember its capacity. So chance should be length, width, and height. And the volume is given in meters cubed or cubic meters. We want these dimensions to be in meters as well. Any ideas so far? How do we approach this? So what do we tell ourselves? What are we looking for in certain numbers? Again, Madison, you're giving me 2 dimensions. Okay, so now,
Miss, that wasn't me.
Madison. So Amari, you're giving me 2 dimensions. I want 3 dimensions, and these must be in meters. Remember, if it is going to have a capacity of 450 cubic meters, so that means we multiply the length by the width by the height, we should get 450 meters cubed. So whatever dimensions you're giving me, and multiply 3 dimensions, we should get 450 meters cubed. That's the idea. I will welcome those who are joining us in the chat. Alexandra, well, not seen this morning, but he did say he would be late this evening. All right, so am I getting any dimensions now? Let me see. There should be in meters, and when you multiply all 3, you should get 450 meters cubed. All right, so here we have some coming in. So Jerry is saying, Jerry, I'm not seeing any units. I must see the units. Okay, so you're saying, all right. So Jerry is saying 75 meters by 2 meters by 3 meters. All right, so yes, that go. All right, Madison said she doesn't understand. So remember, this is a rectangular box. Antoine, if you multiply those numbers, we will not get 450. I promise you that. Let's check again. Maybe if we added them, we would get 450. Remember, we want to multiply them. All right. Somebody, it's a rectangular box, and they told us it should have a capacity of 450 meters cubed. Capacity, volume of a regular box is length times width times height. So we want 3 dimensions, 3 numbers. That's when you multiply them, you get 450. All right, so J is saying 10 meters by 9 meters by 5 meters. That's correct, and that's actually the dimension that I chose for my box. All right, and I are thinking along the same lines. All right, so we have 2 dimensions so far, 10 by 9 by 5 meters and 75 by 3 meters. Let me have 2 more they asked for. All right, Jerry is saying 5 by 18 by 5. Okay, so that is correct. And those are in meters. Can I have one more so we can move on? 3 dimensions that when you multiply them, you get 400 meters squared. Anyone else? Suppose I had the length of the base as 20 and the width as 5, or the width as, let me see. Suppose I had the length is 50, width is 3.
Miss, can I answer?
What would it be?
3 times 3 times 50, miss?
15. If the length is 15 and the width is 3 meters, what would the height need to be? Okay, so Jerry is saying another possibility is 3 by 3 by 50. That's yes. So that then I'm asking if the length is 50, the length of the base is 50, and the width is 3. What would the height need to be in order for that box to satisfy the requirement dimensions? All right, so 15 times 45. So what would we need? Okay, so Madison is saying 10. That's all right. So there dimensions you choose. I am going with 10 meters by 9 meters by 5 meters. All right, so those are dimensions for my box, and that's what we're going to work out the problems that we'll have to solve perform. Each person will have their dimensions and their problems. Their answers will be based on their dimension. Time performance is not a fixed answer. There might be a range of possible answers. Okay, Madison, can you read 1B, please?
Okay. 1B. Draw and label your wooden box, putting all 3 measurements for the dimensions you chose. 1B. Draw and label your wooden box, putting all 3 measurements for the dimensions you chose.
All right, so each person quickly draw your box. Base length, width, and height that you chose. Draw your wooden box. Put in the dimensions. Put in the length, put in the width, put in the height. I'm giving you 30 seconds to draw your box. And then I'm going to draw mine and we can compare and you tell me if something like that. Three-dimensional object is a wooden box. The top is open. We're going to pack coconuts in it. So we need to have the length along the base, the width along the base, and then the height from the base. So let's my box. All right, so I'm going to need, let me use, all right, so this is the top of my box. And these are sides with a height of the box. All right, so did you have something like this?
Miss, you're
And I can put in the dimension.
Yes, miss.
Yeah, something like that. All right,
Yes,
so my
miss.
dimensions, okay, I chose 10 meters by 5 meters. So the 10 meters I'm going to put along here, that's the length of the base. And the 9 meters I'm going to put along here, that's the width. And the 5 meters would be along here. the height. So your box should look something like, if you could have put the height anywhere along these, or even around here if you wanted, right? So that's the length, the width, and the height. All right. So Jaden, can you read number 2? Jaden left. Ari, can you read number 2, please?
Miss Jaden said he is not on stage.
Okay.
Okay, miss.
Ari,
Number
read
2.
2.
Okay, miss. Number 2. For the dimensions that you choose, for the dimension that you chose, what would be the total surface area of each box? The boxes will be uncovered. Number 2. For the dimensions that you chose, what would be the total surface area of each box? The boxes will be uncovered. Miss, I'm finished.
All right. So the total surface area. So that means we're going to find the area of side of the box. Since will be uncovered, we don't have to concern ourselves with the top of the box. So how many surfaces would we need to find the area for? How many surfaces would we need to find the area for? Look at this box. When we talk about the surface area, so this side here, we need to find the area of this side. And we know there's another side around here that matches. We'd have to find the area of this side and the one over here that matches it at the other side. And then we need to find the area of the base that the box is sitting on. We don't have to concern ourselves with the top because they say that the boxes will be uncovered. So they are open boxes. So I'm asking, how many faces would we need to find the area of the surface area of?
Miss 4.
8 faces, 4 faces. Madison says 5. Says 8. Jaden says 4. Antoine says 5. So look, scholars. So this is 1, 2, and the one around here makes 3, and this one around there makes 4, and then the bottom of the box would be 5. We need to find the area of all of those. So for the base, it will be what? 10 times 9. So that's 10 times 9, 10 meters times 9 meters. And that gives 9 meters square. So that's the surface area that the box is on. All right, for the front of the box here, the 10 times 5, and we have another one that's similar to it over here. So we can multiply 10 times 5 times 2 because it's two of them that have the same dimension. So that's 10 meters times 5 meters, and that gives 50 meters squared. And then, so we have this side and that side, we have the base. So now with this face, so that's 5 times, and it's them because one more over here. So 5 meters times 9 meters is 40 meters. So is for the area of the faces. So they want the total surface area. So we need to add those up. So we're going to add the 90, the 50, and the 45. Right? So that's the answer for this question. So it's 90 meters squared, 50 meters squared, 45 meters. Those up, it's 185. So 105 meters squared total surface area of the box. It's uncovered, so we didn't have to multiply the base area by 2 since the box will be left open. So Jaden, can you read now?
Yes, miss. How much lumber? Number 3. Lumber for the boxes can be selected from 2 sizes. Lumber A is 10 centimeters by 50 meters and costs $300 each. Lumber B is 25 centimeters by 100 meters and costs $1,200 each. Number 3. Lumber for the boxes can be selected from 2 sizes. Lumber A is 10 centimeters by 50 meters and costs $300 each.
Sorry, Jaden. This should be centimeters. All of these should be centimeters.
Okay.
All right, read again for me, please.
Number 3. The lumber for the boxes can be selected from 2 sizes. Lumber A, which is 10 centimeters by 50 centimeters and costs $300 each. Lumber B, which is 25 centimeters and by 100 centimeters and costs $1,200 each.
All right, so
Okay.
they want us to work out how much of each lumber we will need and the cost. And the lumber can be joined if necessary. Right, so work out how much of each lumber you will need and the cost, and the lumber can be cut and joined if necessary. All right, so work that out. I'm giving you 2 minutes. Remember the dimensions that you had. For the purposes of the performance task, I'm using 10 meters by 9 meters by 5 meters for my box. But you have to work it according to the dimension. So what I'm going to be doing while you're working out.
Excuse me, miss, can you go back to the slide where it stated the cost and the dimensions, the lumber?
Okay, so we have 10 centimeters by 50 centimeters and $300 each, and 25 centimeters by 100 centimeters, 1,200 each. All right, so everybody jot down those quickly.
Yes, miss.
So what I'm going to do, I'm going to redraw my box putting in the dimensions, this as centimeters, the lumber is in centimeters. That's what I'm going to do. All right, so we're at my 10 meters. So I'm going to put, so there are 100 centimeters in a meter. All right, so that would be 1,000 centimeters. All right, and where I had the 9 meters, so that would be from 9 centimeters. And where I had 5 meters, so that's 500 centimeters. Since the number is in centimeters, so I'm just converting them, because the calculations will now have to be done same unit. Right, so let me know your processes. And some system is going to remove one of the participants. I don't choose who is removed. I think we can accommodate 5 at a time, right? Scholars, that's why you have to try to cover. So let me hear what you're doing. How are you approaching the question?
Miss, I don't really understand this question.
All right. Does anybody want to say what they're doing so far? You know, I should put in the stroke here so that the box open, right? Yeah, to indicate that it's an open box. That looks better. Madison, any ideas how are we going to approach this?
Miss, I started adding all of the surfaces, all of the areas of the surfaces, and then I'm going to get the prices and try to see which one would be better to work with.
Okay. All right, so let me give another minute.
Excuse me, Miss, I don't really understand this question.
Yes, and Antoine, I'm going to go through it. I'm just giving, some scholars are trying, so I'm giving them some time.
Okay, Miss.
To see if they figured out what to do. And then tell you what to do. There are some ways you can solve it. Way. It's not just one way. You can actually, well, what Madison is doing, she's looking at the dimensions of number and is actually going through the surface each side and see which number fits best. And then she's going to work out what number she will need. That's one way to do it. And remember, question just let us know that cut the lumber and join it. We can join pieces together. We can join. So another way you could do it, since we already worked out the surface area of the box, and that will be all the space that the lumber will take up. We could find the area of each lumber and then see how many times that can into the total surface. This would be my preferred approach, especially since that we are going to be able to cut and join the lumber if necessary. So persons who want to try method, right, and see what happens, remember we already worked out the total surface area, and we had gone, what did we get? Hold on.
Miss, we got 185.
180 meters squared. Remember that is in meters, right? 185 meters squared. All right, so that's the surface area. So you could try that approach. You could try that approach with the lumber, find the area of each lumber and see how many times that can go into the total surface area. Or you can work with each face and see how many lumber can fit in terms of the length and the width of each lumber, how many can fit. That is an approach you could try as well. Okay, so any answers as yet?
Miss, I figured out how to do part of the question.
Go ahead, Antoine.
Miss, for the part that says you must find how much the cost of the lumber, Miss,
Yeah.
I worked with B 25 centimeters times 10, $1,200 each. Miss, how I found the cost? Since we're dealing with 5 sides, I times $1,200 by 5 and got $6,000.
Go again from the top, Antoine.
Okay, Miss. I figured out how to do part of the question. The part that says how much it costs. I've been working with the second one B, 25 centimeters times 10 centimeters. So I multiplied 5 by 1,200 since we are working with 5 sides of the cuboid.
But the sides are not equal, Antoine. The sides aren't all the same dimensions. Remember, we have a 10 by 9. Well, for you, your dimensions were what?
Miss, I
What,
have the same.
what was your length and width and height?
Miss, my length is 10 by 9 by 5 as well.
Okay, so you're using that. And I remember those are in meters.
Yes, miss.
The lumber is in centimeters.
Yes,
All right,
miss.
so we changed the centimeters. We changed the meters to centimeters. So we have 1,000 centimeters, 900 centimeters, and 500 centimeters. So the sides are not all the same. I remember we had worked out the total surface area for the sides. And remember, the lumber is going to go across the area of each side. So the total surface area is 185 meters squared. All right, so what I did, since the surface area we worked out is meters squared, I changed the lumber, the dimensions of the lumber, I expressed them in meters. So for lumber A, 10 centimeters would be 0.1 meter, and the 50 centimeters would be 0.5 meters. So the area of that then would be 0.05, which is the 0.1 times 0.5, 0.05. So to how many times that area could fit into the total surface area, we divide the 185 meters square by the 0.05, and we would get 3,700. And the cost would be to multiply that by the 300, since it's 300 each one, and that would give 1,110, sorry, 1,110,000. So for lumber A, we're working with the total surface area in meters squared. So I change this to meters. So meter 0.1 meter. And the 50 centimeters is 0.5. So the area of this lumber is 0.1 times 0.5, which is 0.05. So when we multiply them to get the area of the lumber itself, 0.05, that is meter squared. The area of this, so the 25 centimeters is 0.25 meters, and the 100 centimeters would be 1 meter. That multiplies to give 0.25 squared. That's the area of this lumber. So we can check each lumber to see how many times it can go into the 185 meters squared. So 185 divided by the 0.05, and we got 3,700. The cost of each one is $300. So we multiply 100 to get the cost. And lumber B, the 185 meters squared divided by 0.25 would give us 740 piece of lumber. And since it's 1,002 for east, that would be $888,000. All right, so let's go on
Miss,
now.
can you repeat number B on my, because on my side you were lagging.
So what we did was we found the area of each piece of lumber. First, I changed the centimeters to meters, since the unit that we're working for the total survey was meters squared. So this is the area of lumber A, this is the area of lumber B. And I divided each one into the total surface area to see how many of each one could hold. And then I multiplied that by the cost of each lumber. So for lumber A, it would be $1,110,000, and for lumber B, it would be $888,000. Here. All right, Jared, the question, please.
Break time. At break time, the students are given some delicious coconut water to drink. Each mature coconut contains 1.5 liters. How many 250 milliliters glasses can be filled with the water from 4 mature coconuts? At break time, the students are given some delicious coconut water to drink. Each mature coconut contains 1.5 liters. How many 250 milliliter glasses can be filled with the water from 4 mature coconuts?
All right, work that for me, please. Welcome those who are just joining us in the chat. Tashika is saying she doesn't understand, but I think that was before I explained again for and so Tashika, you can always play back this video where I just do explanation again. In summary, with the area of each lumber, and we saw in meters squared, and we divided it into the total surface area. It already worked in the last of the question before this question. So we divided it to see how many of the lumber and multiplied by the cost of each lumber. All right, Jared, tell me how you got 24, please.
Miss, so if one mature coconut has 1.5 liters of coconut juice, and there are 4 mature coconuts, and if I break down 1.5 liters into milliliters, it's gonna give you 1,500. So times 1,500 milliliters by 4, because there are 4 mature coconuts, and it gives me 6,000. Then I divide 6,000 by the 250 milliliter cups, and I get 24.
Excellent. That's correct.
Miss, I agree with Jer.
I agree with Jared.
Also agree.
Yes, Miss.
Someone in the chat is wishing us. Okay, so Matt is 24. Well, Jaden got the same. Antoine got the same thing. All right, so we're all on board with that question. Someone in the chat is us all Happy New Year. That's Miss Authenticity. I think it's pronounced Miss Authenticity. Happy New Year to the class and the teacher, my beloved. All right. Thank you, Miss Authenticity. And guys, Happy New Year for those who are just joining us for the first time this year. All right. So, how many coconut halves would you obtain from 23 whole coconuts? So tackle this one for me. Coconut halves. Like what
Miss, do we
in the
divide
picture, the half of a coconut.
Miss, do we divide 23 by 2?
Miss,
Miss,
Miss, may I answer?
Go ahead, listen.
I say we times 23 by 2.
Go ahead, listen.
Miss, did you hear
Why
my
not
answer?
divide? Jaden, Jaden, yes, I'm hearing. Jaden saying that we. Why are you saying we should multiply?
Miss, because they didn't ask, how do I explain it? They didn't ask us to find half of our coconut. I don't know how else to explain it. They asked how many halves would you get from the coconuts?
Right. So splitting each one into two is like we're multiplying by 2. When we take 1 and we split it into 2, we're still getting from 1. So 2 would give 4 halves and so on. So
I see my mistake. I agree with this.
right. So it's 46. And Miss Gamble come in the chat. She's also saying she got 46. Jer got 46 as well. All right. Let's go on.
See, look, you know, he's a fan now. What's the fan of blow?
Okay. The farm produces delicious coconut milk.
All right. So here's the actual question.
Oh, yeah. The pulp from 3 dry coconuts will produce 5 liters of rich coconut milk. Number 6. How many dry coconuts would be required to produce 40 liters of coconut milk? The pulp from 3 dry coconuts will produce 5 liters of rich coconut milk. Number 6. How many dry coconuts would be required to produce 40 liters of coconut milk?
All right. Okay, how do we approach that one?
Miss, is it 24?
How did you get 24?
Miss, if 3 dry coconuts will give you 5 liters, I divided the 5 liters into the 40 liters of coconut milk, and then I would get 8. Then I times 8 by each individual 3 coconuts I would use, and I get 24.
Right. Okay, so Mrs. Ben Campbell is also saying 24.
Miss, I got 24.
I got 24. Yes, I got 24 as well. All right, we have our final question, Madison. Can you do me the honor of reading this last?
Okay, Miss. Coconut seeds. The students found some immature coconut seeds under the trees. If each student was given 2 of the seeds as souvenirs, how many seeds were given to them in all? Coconut seeds. The students found some immature coconut seeds under the trees. If each student was given 2 of the seeds as souvenirs, how many seeds were given to them in all?
Do you remember
Miss,
how many students there were?
No, Miss.
All right, so let's go back and double check how many students there were. How many students?
35.
So
Miss,
there
are
were
there
30
70 students, 70 coconuts seeds, Miss?
70 seeds.
Miss, because each student gets 2.
All right, so there are 35 students, and each student is given 2 as souvenirs. All right, so it's a multiplication problem,
Miss
right?
70 seeds. I agree.
Multiply it by 2, yes,
All right.
I also agree.
I agree, Miss.
All in favor say aye. All in favor say aye.
I.
I
I.
I.
All right, I agree as well. All right,
Me,
so
myself,
I don't
and
believe someone is just joining us. Well, we're heading on out here because I have a CSEC class in a couple sessions now. Really pleased with your performance. As usual, my was very brilliant, very open and confident. I'm so proud of you all. Thank you to those who joined us in the chat from wherever in the universe you are. You are all welcome to join us. And feel free to post your questions, answers, and your comments. We are appreciative of company. Tomorrow, what do we have tomorrow? Tomorrow, Thursday. What's on the schedule for tomorrow? I need to play the schedule for you again. All right, so as soon as we wrap this up, I'm going to play the schedule for you so you see what we have planned for tomorrow. Remember, 5 PEP classes per week, 6 CSEC live classes per week. These are live classes I'm talking. So that's different from the videos that we upload to the channel. We have over 350 videos on the channel where you can go and set up your camp, set up your tent, camp out on the channel. We have videos on all topics in mathematics from grade 4 up to C level. So take advantage of those videos and join the live classes where you can participate and questions, you can post your answers and see if you're on the right track. All right, so asking for WhatsApp numbers. Okay. All right, so scholars, good night. Some rest. I will see you.
Okay, Miss.
Good
Bye.
night, Miss. Bye.
Good night. Bye,
Good night.
Miss.
See you tomorrow.
night, miss.
Good night, scholars. Hello, CSEC math students. I know you are preparing for your test and your CSEC exams coming up. Very important questions. Do you like me? Thank you. Another important question. Have you ever gotten a math problem wrong simply because of one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at common mistakes that's made with all the topics in math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If you know the errors beforehand, you can certainly avoid making them. Are you ready? Come on.